Welcome back, children. In the last class, we had talked about a few concepts of gravitation. Let us have a small revision of what we have done. So, we talked about free fall. What did we discuss in free fall? We discussed about acceleration due to gravity also. That if an object falls only under the influence of gravity, we call it as free fall. So when a body is falling freely, there is no other external force. So we say no other external forces involved. We also discussed about acceleration due to gravity. We found out the derivation. We derived the formula small g is equal to capital G capital M by r square, where small g is the acceleration due to gravity. So if you put the values of capital G is equal to 6.7 into 10 power of minus 11 Newton meter square per kg square, and if you put the value of mass of earth to be 6 into 10 power of 24 kg, and radius of earth is equal to 6400 kilometer, means it would be 6400 into 1000 meter, then you would get the value of G earth to be approximately equal to 9.8 meter per second square. We have discussed this in the last class. If you talk about the moon has got the mass of moon is nearly 1 by 100 times the mass of earth, and the radius is, if you put the values of mass of moon and radius of moon, you would get G moon is equal to 1/6 of G earth. We will discuss this later on when we talk about mass and weight. You would get as the value as 1.63 meter per second square. Now if you look at this equation, G is equal to Gm by r square, this equation does not contain mass of object. So we also discussed that why acceleration due to gravity is independent of the mass of object. G does not depend on the mass of object. So these are the things we learned last time. So in continuation with that, let us move further. We will be talking about equations of motion of a freely falling object today. So when a body is falling freely, when a body falls freely, it is accelerated. What is the acceleration value? If it is on earth, it is it is 9.8 meter per second square. Now if we say 9.8 meter per second square, what does it mean? In every 1 second, in every 1 second, the velocity of the body increases by 9.8 meter per second. So it is accelerated. And if a body is having acceleration, then the equations of motion which we discussed in chapter number 1, they hold good. Means here also we can use acceleration, the equations of motion which we learned in chapter number 1. So let us have a quick revision of those three equations. The first equation was v is equal to u plus at, and this equation is called velocity time relationship. Now if a body is falling freely under gravity, acceleration due to gravity is written as g. So this equation would change into v is equal to u plus gt, where g is the acceleration due to gravity. And what is the value of g? It is 9.8 meter per second square. And for calculations, for making the calculations easier, we sometimes take g, the value of g, to be 10 meter per second square. If it is given in the question, you must have to take g is equal to 10. Otherwise, if it is not given, then we have to take the value of g to be 9.8 meter per second square. When we talk about the numericals, we will discuss these things. The second equation of motion that was there in chapter number 1 was s is equal to ut plus half at square. S is the displacement and A is the acceleration. So this equation was called as position time relationship. Position time relationship, because it decides where the body is after a certain time. S is the distance or displacement, which we can say in class 9 you may say distance and displacement are same. Now this equation, when we talk about a freely falling body, s becomes height. So the equation becomes h is equal to ut plus half gt square. So this is the second equation of motion for a freely falling body. Okay. Now the third equation that you learned in chapter number 1 was v square minus u square is equal to 2as, and this was called as position velocity relationship. Now here again, if you replace a with g and s with h, this equation changes into v square minus u square is equal to 2gh. So this is the third equation of motion. Now when we are using these three equations of motion, we have to be very careful. Now what could be the points to be remembered in these cases? When a body is thrown up, when a body is thrown up, it is going against gravity. So in this case, a body thrown upwards, this goes against gravity, against gravitational force, we can say. So there would be retardation. So in this case, we would have a retardation, and in this case we would get g as negative. So when we are solving the question and the question is given a body is thrown upwards, we have to take g as negative or minus 9.8 meter per second square or 10 meter per second square, depending upon the values. In this case, we will be using some information. When a body is thrown up, when a body is thrown up, What are the things to be remembered? G would be negative. And what will happen when the body is moving up? If you throw a body upwards, the body would slowly and slowly come to rest. So at the highest point, if you're throwing a body upwards, it would stop after some time. So we take final velocity as 0. We will take final velocity as 0. Initial velocity is not equal to 0. Initial velocity is not equal to 0. Final velocity is equal to 0 in this case. So when a body is thrown upwards, the value of final velocity would be equal to 0. Initial velocity is not equal to 0, and g is always negative. A second type of a situation, a body is dropped from certain height. When a body is dropped, when a body is dropped, so you are dropping a body, it comes down due to gravity. So in this case, u would be equal to 0, initial velocity. Initial velocity is 0 and g is taken as positive, or you can say plus 9.8 meter per second square. So g is positive, u is equal to 0, and certainly when it is falling towards the ground with gravitational force, when it hits the ground, the final velocity would be the maximum. Okay. The third important condition, the third important thing that we have to remember when a body is falling freely. If a body is thrown up, if a body is thrown upwards, and it returns back, to the ground, then what is the important thing that you have to remember here is the time of ascent, means whatever time it takes to move up, this is the maximum height. Let us mark this as the maximum height. If it takes time t from A to B, time taken from A to B, if it is t, what would be the time taken for the body to come down again? It would reach the maximum height and then it would return back. So when it returns back, again it would take the same time. So time taken from B to A is also t. So we have to remember a point here. Time of ascent would always be equal to the time of descent. So whatever time it takes to move up, it would be same as the time taken by the body to reach to the ground again. Another very important thing, if you are throwing the body with a velocity u, if u is the velocity with which you are throwing the body upwards, if u is equal to the velocity with which a body is thrown up, what do you expect about the velocity with which it would again return back? It returns back to the thrower's hands with the same velocity. So these are some of the points which you have to remember when we are talking about equations of motion of a freely falling body. Now, based on these equations, let us first solve a few numericals in today's lecture. Okay, let us take a few examples which are given in your book. You may find some examples in your book. We will also solve a few questions from your exercise also. So the first question let us talk about is, let us take this question. A particle is thrown up with a velocity of 50 meter per second. You may note down this question also. This is, let us say, question number 1. A particle is thrown up vertically with a velocity of 50 meter per second. What will be the velocity? What will be the velocity at the highest point of the journey? At the highest point of the journey. This is the first part of the question. And what is the second part? How high would the particle rise? How high would the particle rise? Is the second question. And the third question is, what time would it take to reach the highest point? These are the given questions. There are three parts in the question, and what is the value? Here they have taken take g is equal to 10 meter per second square. Now this is the question given. Now let us solve this question first. Now whenever you are given a question, please try to draw a diagram for the given question. The question is, a particle is thrown up vertically upwards with a velocity of 50 meter per second. So if I draw the diagram for this, this is the first part. A particle is thrown up. So initial velocity is given u is equal to 50 meter per second. So from this point, let us mark it as A and B. B is the highest point, let us say. This is the highest point. So when it is thrown up, initial velocity is 50 meter per second. What will be the velocity at the highest point? Just now we have discussed that when a body is thrown up, it goes against gravity. So at the highest point, as the body is moving against gravity, as the body is moving against gravity, therefore velocity at highest point would be is equal to 0. Okay, now how high would the particle rise? So what are they asking in the second part of the question? And what would be the height attained by the body? So we need to find out this height. And the third part is, how much time would it take to reach the highest point? We need to find out the time taken by the body also. So u is given to us 50 meter per second. Final velocity is 0. So u is 50 meter per second. Final velocity is 0. V is equal to 0. G is equal to minus 10 meter per second square. Just now we talked about that it is going against gravity. So V is 0. G is equal to minus 10 meter per second square. We need to find out H and we need to find out T. So you see what are the equations now? U, V, G and T. V is equal to U plus GT. This is the equation that we have, the first equation. So V is equal to 0. Initial velocity is 50 meter per second square plus minus 10 into T. So we get 0 is equal to 50 minus 10T, or T is equal to 50 divided by 10. So we get 5 seconds. So the time taken by the body to reach the highest point is 5 seconds. Now we need to find out H. You can use the second equation or third equation. H is equal to ut plus half gt square. This we can use very easy. U is 50, time we have just calculated is 5 plus half into minus 10 into t square is 5 whole square. So this is 250 minus, because plus we have got minus 10, so 2 into 5 is 10. So 5 into 25, it is 125. So the height attained by the body is 125 meters. So this gives you the answer of the question. Okay, let us move on to the next question. Next example. Let us see what is given in the question. Let us see another question here. Okay. So the question is, a particle is dropped from a tower 180 meter high. So let me write down the question. Question number 2. A particle is dropped from a tower 180 meter high. How long does it take? How long does it take to reach the ground? This is the first part. And the second part is, what is the velocity? What is the velocity when it touches the ground? Again, the value given for G is, they have given take G is equal to 10 meter per second square. Now let us see this question. The question is, a particle is dropped from the tower 180 meter high. So if we draw a tower which is 180 meter high, so let us draw the tower first. So imagine this as the tower. This is the tower, and this height is given 180 meter. This question is given, a particle is dropped. Is dropped means the initial velocity of the body is 0. So what are the things given? Given u is equal to 0. H is equal to 180 meter. What is the velocity when it touches the ground? Means we have to find out the body is dropped from here, so it comes down. So when it hits the ground, we need to find out the velocity here. So we have to find out the velocity, final velocity v, and g is given 10 meter per second square. Now if you look at the values u, h, v and g, so we can use the second equation of motion, sorry, third equation. We can use v square minus u square is equal to 2gh. We can find out the velocity from here, and then we can find out the time also. UVT. So if we want to find out time, so T is equal to V minus U by A. This you have read in chapter number 1. So this can be written as V minus U by G according to the question. So what would be the value of T here? This is, oh sorry, we don't know the value of V. So we need to find out H first. So can we use this? No, because we don't know the value of V. So let us first find out the value of H. So V square minus U square is 0 is equal to 2. G is minus 10. Sorry, it is plus 10. 2 into plus 10 because it is falling downwards and the height given is 180 meter. So V square is equal to how much? 2 into 10, 20, 20 into 18. So we get 3600. So V is equal to 60 meter per second. This is the value we get. V is equal to 60 meter per second. Now this value can be used to find out the value of time. So T is equal to V minus U by G. So this would be V is 60 minus U is 0 by G is 10. So 60 by 10 we get 6 seconds. So the time taken for the particle to reach the ground is equal to 6 seconds. The final velocity with which the body is going to hit the ground would be 60 meter per second. So this is question number 2. Let us move on to the third question on equation of motion. Let us see some NCERT questions. Some questions on NCERT in text questions. Now let us see this question. A ball is thrown vertically upwards with a velocity of 49 meter per second. Now there is something interesting. Let us see this question first. The question is, a ball is thrown vertically upwards a ball is thrown vertically upwards with a velocity of 49 meter per second. Calculate the first part is the maximum height to which it rises, the maximum height to which it rises, and the second part is the total time taken it takes to return to the surface of Earth. The total time it takes to return back to the surface of Earth. So I told you earlier also that we need to uh, draw the diagram of these type of questions first. Drawing a diagram makes it very easy to understand and what equation to be used. So the ball is thrown vertically upwards, so the ball is moving up, and when the body is moving upwards, I have already told you that at the maximum height the velocity would be 0. So what are the things given? U is equal to 49 meter per second. Final velocity is 0. Now something very interesting here in this question, they have not specified to take g is equal to 10 meter per second square. Now very important, please try to understand this. If you are reading the question and you find some values which are the multiples of 9.8, like here you have got 49, so we know 9.8 into 1 is 9.8, 9.8 into 2 is equal to 19.6, 9.8 into 3 is equal to 29.4, and similarly if you keep on multiplying into 5 we get 49. Now if you look at this question, we have got 49, so indirectly it means that you cannot take g is equal to 10 meter per second square. If you take g is equal to 10 meter per second square, you would end up in some complicated calculations. So if you take g is equal to 9.8 meter per second square, then your calculations would be much easier in this case. So what are the things given? The third part that is given in this question is g is equal to 9.8 meter per second square. This is the value given. We need to find out the maximum height it goes, and the total time means if we find out this time to move up, we can multiply this same into 2. This would also be time t. So let us find out first h, and then we have to find t. After we find out t, we can multiply it with 2 to get the total time taken. So u, v, g and h. So we can use v square u square 2gh in this case. If you use these values, we have been given uvg, so we can find t also by using equation number 1. T is equal to v minus u by g. Now a body is thrown up, so what is the value of g? Now if you look at this question, this is against gravity, against gravity. So in this question we need to take the value of g to be minus 9.8 meter per second square. So this would give me the values as, if you put the values, v is 0, minus u is 49 by minus 9.8. So it is minus 49 by minus 9.8. So minus and minus get cancelled. You get 5 seconds. So 5 seconds is the time taken by the body to move up. So if it is taking 5 seconds to move up, what would be the time taken to come down? It would again be 5 seconds. So the total time taken by the body to reach the ground. So from here we get the total time taken by the body to reach the ground is equal to 2t. So it is 2 into 5. So we get 10 seconds. Okay, so time taken is 10 seconds. We need to find out h now. You can use any equation, v square minus u square. Let us use this, the third equation. V square minus u square is equal to 2gh. So h is equal to v square minus u square by 2g. Now put the values. V square is 0 minus u square. What is the value of u? It is thrown up with a velocity of 49 meter per second. So u is 49 into 49. So it is 49 whole square by 2 into minus 9.8. So this is minus 49 multiply 49 divided by minus 2 into 9.8. So you can see minus and minus would get cancelled. This cancels. Now you see the values, 9.8 into 5. You can cut this with 5. So this is 49 into 5 by 2. So 49 into 5 is 245 by 2. We get 122.5 meters. Now in these questions, whatever we have discussed in today's lecture was how we are going to use the equations of motion in a freely falling body. When a body is falling freely under gravity, we can use these three equations. And what are the things to be remembered when you have been given g is equal to 10 meter per second square? You must take 10 meter per second square so that the calculations become very easy. But if it is not given and you are reading the question and you are finding that the question has got some multiple of 9.8, then you must always take g is equal to 9.8 meter per second square. So let us wind up today in this lecture. What we have learned, revise it thoroughly so that whenever we meet next time, we would be continuing with some more typical questions on equation of motion of freely falling body, and then we would be talking about mass and weight. Thank you so much.